All right, welcome back to Mr. P-Ups with Calculus. This is Unit 3, Day 1, and we're going to be talking about the chain rule, something you're going to use all year long. Quickly going through that activator. So the chain rule, two of these questions right here are going to need the chain rule, and two of them are not. And we need to identify what the difference is. We have learned that when you find the derivative of f of x, you get f prime of x. The derivative of cosine of x is negative sine of x. So there's no chain rule involved there. That's just a pretty straightforward question. But when you look here, what we really have is a function inside of another function. And that's why you have to use chain rule. So if f of x is this entire thing, and I call this g of x, but that's not really the thing. So we have what's an inner function here, and then we have the outer function. So if I call all of this 4x plus 5, if I call that u, if I say u is 4x plus 5, and this would be u to the 12th power. So that would be the outer function would be to the 12th power. So that's the outer function, and this is the inner function. Same thing with number 4, has an outer and an inner function. Cosine of the argument is the outer function, and then the inner function is just 2x. Okay, this is kind of the same thing I was just talking about a second ago. It says the chain rule allows you to take the derivative of a composite function. Composite functions are a combination of two or more functions, and yet usually I think AB Board doesn't go past 3, but yeah, it could be a function inside a function inside a function inside a function. It's possible it could be 4, I suppose. I mean, theoretically it could be anything, but typically they try to keep chain ruled to 2 functions, sometimes 3 functions, and I don't know if you're going to see past that. All right, so if we have a function x squared plus 1, these are all simply just one thing. Over here, we have a function inside of a function. This is a composite function. This is all raised to the 1/2 power, or sine of, and then we have the inner function. This is the inner, and this is the outer. So that's the way you always want to think in terms of what's the inner function and what's the outer function. The inner function is here, and this is the outer function. The outer function would be raised to the 5th power. Now, the x here is just a single function. Now, keep in mind, there is an addition sign there. So we do have the addition property of, we have this, a sum and difference property here. This tangent of x squared, this is the argument. So the outer function is tangent of the argument, and x squared is the inner function. But the x itself is just the derivative, just 1. All right, so take a look at how do we do it. Well, the rule is up here. So this is what the chain rule is. The chain rule is technically just find the derivative of the outer function and multiply it by the derivative of the inner function. That's what this is essentially just saying. So if we have f of g of x, and we're going to take the derivative of that, so what you do is you take the derivative of the outer function, that would be the f prime of g of x, that's the derivative of the outer function, and multiply it by the derivative of the inner function. And that's it. It's not really as hard as it might look up here. So it's the derivative of the outer function times the derivative of the inner function. All right, so the derivative of the outer function is to the 4th power. So what you would do is you would bring that down in front using your simple power rule, lower it by subtracting it by 1 to 3. So this is the derivative of the outer function, and then you're going to multiply it by the derivative of the inside. So 2 times 5 becomes 10, so that's 10x. 1 times -4 is -4, and the derivative of any constant, you should already know by now, is 0. And then from here, all I'm really going to do here is multiply anything with the same degree. Now you can see I put a 1 right here because really all of this is raised to the 1st power. This 4 is to the 1st power. All of this is to the 3rd power. So you cannot multiply. You cannot distribute this 4 to this because it's protected by the 3rd power. You can, however, and this is important for the multiple choice questions because maybe this is the answer on the multiple choice, or maybe they're distributing that 4 to this bracket over here, this parenthesis over here, which happens to have the exact same exponent. So something you want to be aware of, because this could commonly right here be the answer on the multiple choice, because you never know what you're going to expect. All right, so for this question, we have the outer function here, and we have the inner function here. The inner function obviously is going to be inside something, either parentheses or brackets or absolute value symbol. It could be anything. It's going to be inside of something, though. All right, the derivative of the outer function is secant squared, so it's secant squared of 3x squared. You don't do anything to the inner function when you do the outer function. It's just the derivative of this, and keep this the same, multiplied by the derivative of the inner function, which is 6x. Now, this could be the answer. A lot of times they like to put the trig functions last and just rearrange the order. That's all I did here. So very commonly you're going to see like coefficients and x's go first before the trig functions. So that way you don't really feel the need to put a multiplication symbol there. I don't know, it just kind of looks a little bit cleaner. All right, first thing you're going to want to do is change this to rational. You want to always get rid of radicals so that you can use your simple power rule. And the simple power rule, so this is your inner, and this is the outer function. So you're going to bring this down, lower this by 1, subtract 1 from 1/2, makes it negative 1/2, and then multiply by the derivative of the inner function. Now the rest is just cleaning up and making it look a little bit neater by simplifying. All right, so we have the outer function of cosine, and then the inner function is simply that linear 6x. Derivative of cosine is negative sine of the same argument, and then multiply it by the derivative of the argument, which is 6. Pretty simple question there. All right, so first thing I did was change the y equals to make it into rational form. Then to find the derivative of y, so we bring this down, subtract it by 1, then multiply it by the inner function. So the outer function's been done using simple power rule, and then multiply it by the derivative of the inner function, and then clean it up just to look a little bit nicer. All right, so we have the inner function here, and then the outer function here. Technically, you could use your constant multiple rule for the 3. But I'm just going to leave it there because I'm going to just multiply 4 times 3. It doesn't matter which way you do it. If you pulled the 3 out, you're going to end up multiplying 3 times 4 anyway. So 3 times 4 is 12. Drop this by 1 to 3. Keep the inside the same. The inside doesn't change when you do the derivative of the outer function. And then the derivative of the inner function just happens to be negative 9, and you're done. And then just make it a cleaner look. And what do we got? 2 more examples. Let me go back. Just wanted to see how many more we had. All right, so we got a couple here. 7e to the 5x. All right, a little bit tricky. Constant multiple rule for the 7. You could just push that aside and multiply 7 at the end. All right, e to the, this is the inner function, this is the outer function. So think of e to the u. Remember, the derivative of e to the u is e to the u itself. So the derivative of the outer function is itself. The derivative of the inner function is 5. And then you can clean this up by multiplying the 7 times the 5, and you are done. All right, number 8 over here. First thing I would do is take this. Now, I'll be honest. Number 8, at first look, maybe your brain went the same way as mine. I was thinking, hey, maybe I could use quotient rule. Actually, I think quotient rule probably wouldn't be a lot of work either. But you don't have to. You have options. You can use any rule as long as it can be applied. Yeah, quotient rule is a possibility to find the derivative if you want to do it that way. But it might be easier just to use the chain rule by turning this into a multiplication problem. Turn it into 1 times x to the third minus 5 to the negative first power. So now essentially you turn it into multiplication. But the 1 times, it's not really multiplication because 1 times anything is itself. So this is not product rule. You could either use chain rule or you could use quotient rule. Product rule is not really an option here. Now, to use chain rule, so we have an inner function here and an outer here. So we drop this down in front, drop it by 1, that's simple power rule, and then multiply it by the derivative of the inner function, which is 3x squared. and then it's just a matter of cleaning it up. And if you kind of analyze your answer, you can see the bottom is squared just like in quotient rule, and then the top, if we had done quotient rule, would have simplified down to negative 3x squared. Yeah, you would have gotten the exact same answer, and like we do on quotient rule, we never really mess with the bottom anyway. All right, last one. What do we got here? Oh, first glance, I am noticing something. Maybe you've noticed, maybe you haven't. I've kind of given you a chance to look at it. I've been stalling. But we've got 3 functions here. So we have the cosine of x, which is the most outer. We have the 3x, which, I'm sorry, that is not true. The most outer is, think of it as this, cosine of 3x. I just said it wrong. Think of it as this. This is the most outer. This is the middle function, and then this is the most inner function. Now, when you do chain rule, you're just going to do it in the steps from most outer to most inner. So most outer, so this 2 gets pulled down here, times all of this. You don't do anything with that inside, even though it's really 2 functions. So that's cosine of 3x. It drops down to the first power. That's kind of useless. Okay. So this right here is my first round of using chain. I did the most outer function. Now I drop to the middle function. So the derivative of cosine is negative sine of 3x. That gets rid of my middle function. And then I have to multiply that again by the most inner function. The derivative of 3x is 3. So, like I said, yeah, this is actually not a totally uncommon thing. It's kind of a rare thing to see 3 chains that we'll be doing this year, but it definitely occurs. I'm going to say not quite often, but it does happen. It definitely does happen. 4 chains, I think, is extremely rare. I've only seen that a few times, and anything above that, I just don't think that you're going to have to worry about. But yeah, definitely. We need to get some practice on triple chaining, so ones with 3 functions involved. All right, thanks again for watching, and I'll see you on the